If we don't act, we lose time because that next big impact could come tomorrow or it could come next year.
Irma, Michael, Ian. These Category 4 and 5 hurricanes hit Florida within the last 5 years, as did several smaller storms. They've destroyed homes and businesses, totaling over $200 billion in damage. It's not a fluke, it's a trend. Strong storms are landing with increasing frequency, and yet our coasts are largely unprotected. So how can we strengthen coastal communities against wind and waves? That's what the University of Miami's Sustain Lab is trying to figure out, using a state-of-the-art hurricane simulator.
So you can customize a hurricane, create a hurricane, build a hurricane, and study specifically what you want. So this is a computer that controls wave.
Soon, Chanton will activate this 1,460 horsepower fan to unleash a hurricane within this 38,000-gallon tank. Payson and the rest of the Sustain team are developing solutions to help communities withstand hurricane waves, which on the coast cause more damage than wind. First, they must understand how waves form and how they transmit energy.
If you have a calm surface and the wind starts to blow, there's some initial perturbations. The wave starts to form very small waves first.
This is a monochromatic wave with a 7-centimeter amplitude, which is like a rough wave in the ocean.
Over time and distance, the waves continue to grow as the wind pushes on the forming waves.
And now I think we're already in a Cat 1 intensity right now. There are tons of sprays and bubbles all over the water surface.
The wind is pushing against that water and adding energy to the water, energy and momentum. So as that wave continues to propagate and grow, all that wind energy is going into those waves and they can become very large.
Because of the weight of water, the larger the wave, the more energy it transmits.
1 cubic foot of water is 64 pounds. If we take 4 cubic feet of water, it's basically the average weight of an NFL player. Now imagine an NFL player running into you and basically tackling you. Now imagine a sea of NFL players coming into you and then coming again and again.
We're at a Cat 5 full intensity right now. The sea sprays are going all the way out.
Category 5 waves may look a mess, but there is an organized wave motion here, propelling the weight of water towards our coasts. Coasts that once looked like this. This is St. Vincent Island in the Florida Panhandle. It's a national wildlife refuge, and a glimpse at what had once been one of Florida's best natural defenses against hurricanes, barrier islands.
Over the pre-settlement times in Florida, the barrier islands were natural. They basically served the function of protecting the mainland from storms and things like that.
Florida was further protected by other natural systems.
Natural systems like salt marshes, seagrasses, oyster reefs, coral reefs, even mangroves, they all kind of protect us, but they all need space and time.
In much of Florida, these natural systems have been replaced by human structures built directly on the coast. Miami Beach, for example, is built right on a barrier island. The Sustain Lab designs barriers to protect those hotels and condos from wave energy. The challenge is to engineer a barrier that will slow down the waves in the same way natural systems would. Their designs are tested in a hurricane simulator.
So what we want to avoid is that energy transfers by impact into the structures.
Traditional construction of things like seawalls. So a seawall doesn't take any energy out, it bounces energy off of it.
But sometimes this also worsens up the conditions in nearby areas.
The key thing for waves is they go into things like salt marshes, oyster reefs, seagrasses, mangroves. They disrupt the motion of the water.
If we can actually dissipate the energy by breaking the waves, so turbulence, and you do it on the right locations, when they arrive at the shoreline, you'll have less impact.
To do this, Sustain has developed a hybrid approach called Sea Hive that combines engineering with natural systems.
The sea hive is a way to replace a traditional sheet pile seawall with something that is perforated, something that can dissipate more energy locally as opposed to just reflect it, which is what happens with the seawall.
The units are hexagonal prisms, hollow in the inside, with a series of holes on their side faces. So what happens there is we pile them up vertically or horizontally.
The holes slow down wave energy and can be used as planters for mangroves, marsh grasses, and coral reefs, which further break up the waves.
So create kind of like a living shoreline, a hybrid system that we can adopt.
Sustain is working towards deploying sea hive modules to test sites within the next year. If they work, they could be strategically deployed more widely over the coming decades, helping to buffer the impact of storms. In any year, anywhere in Florida, a Category 5 hurricane can hit.
With climate change and rising temperatures, the densification of the coastlines, I mean, it's almost kind of like the perfect catastrophe scenario for the communities. So luckily, we have been doing better in terms of preparation, in terms of our codes, in terms of construction. So whenever we develop something, we want to make sure that this could be used to protect not only the vulnerable regions, but also the vulnerable population.
So I am very happy to be here with our panel. So on the panel, down the end, as you've met, Rob Diaz de Villegas, the ecology producer for WFSU Public Media, who produced that wonderful report we just saw. And next to Rob is Jeffrey Chanton, who is the Lawton Professor at Florida State University, Department of Earth, Ocean, and Atmospheric Science. And next to me is John Morales, who you saw in the NOVA clip. John is an atmospheric and environmental scientist and a meteorologist and the hurricane specialist for WTVJ in Miami. So thank you all so much for being here. So John, I wanted to start with you, and I would love to have you talk about the relationship between climate and weather, and especially about extreme weather. So we touched on this a little bit in the clip we saw, that the idea that more heat in the system can make things warmer overall, and that's kind of pretty intuitive and straightforward. But how does it make things weirder? Why is it that some areas may see more extreme cold, as well as warm weather or bigger snowstorms? For some people, it seems like, well, it's colder now, so that climate change isn't a thing. Why doesn't it just turn up the thermostat uniformly everywhere?
Well, good evening to everybody, and it's great to be here. So first, the basic difference between weather and climate, right? So climate is what you expect, weather is what you get, right? So, right? And climate, the climate averages are changing slowly, or at least historically have changed slowly. We're quite concerned about how rapidly the climate is changing now, because of course, we've supercharged the system with our greenhouse gas emissions. Now, there's a lot going on with a warming climate, right? So the most basic idea is, okay, well, we are trapping more heat in the atmosphere and the oceans, because, by the way, the oceans are absorbing a lot of the heat as well, okay? And as we do that, what's the first thing that logically should happen? Yeah, our temperature should be rising. And are we seeing more intense heat waves? Are we seeing more frequent heat waves? Indeed, we are. And there's a concern that, as this continues to happen, the number of dangerous heat days, like what was presented in the program, in places like Atlanta and in Phoenix, are going to continue to multiply. So these are days when, agricultural workers and construction workers, or even folks who want to go out cycling or jogging or whatnot, are in danger. And those days are multiplying. And again, heat is the silent killer. But what else is changing? Well, the hydrologic cycle is accelerating as well. As temperatures rise, we evaporate moisture faster. So droughts can happen with greater ease and be prolonged by the warmer temperatures. At the same time, a warmer atmosphere can sustain more water vapor. And events like what was seen a week or so ago down in Fort Lauderdale are happening worldwide more frequently. And you know, there's a lot, and I'm not going to go into it right now. There's a lot that impacted the Fort Lauderdale situation, including infrastructure just simply not being designed for that level of rainfall, and who could design, right, something for that level of rainfall. But those events are happening with greater frequency too.
So how about cold?
Yeah, so first off, the temperature trends in all these places, including places where we've seen some pretty headline-making events, like the one in Texas in, I think it was 2021, maybe February of 21, where they had all the horrific cold and the power outages and basically people becoming hypothermic and passing away because of the cold. Well, despite that event, which might have lasted a week or so, the general trend in temperatures in Texas over the last 50 plus years is up. Things are warming despite these short-term events. You can get these extremes happening because the jet stream is wavier now than it was in the past. We're getting more undulations in the jet stream, which may be linked to climate, but we're not sure because this is emerging science, okay? There's still some controversy about this. But what gives us an energetic jet stream? The difference in temperature between the mid-latitudes where we sit at and the poles. If the poles are warming very, very quickly compared to the rest of the planet, which they are, because you've heard about the Arctic and how fast it's warming, and you've heard about the Antarctic. Those places are warming very quickly. The difference in temperature between the poles and the mid-latitudes is not as much. The jet stream is weaker. A weaker jet stream, what does it do? It meanders more as opposed to zipping along from west to east.
Could I add something?
Yes, please, Jeff.
So first I want to say thank you to my oceanography class that came to get
All
credit
right.
for this.
Yay.
Extra credit. Extra credit. Email me, and the secret word is subduction. Don't tell anybody. Just email me that word tomorrow or tonight. And the thing I'd like to add to that is that the overall long-term mean of climate is towards warming, but when you juice the system, when you add all that energy to it, you also increase the variability. And so you're going up, but you're also spikier. And that's what we see when it's cold.
So you're seeing extreme cold and extreme heat here.
There's more variability.
Right. You can, I guess a better way to express that is you can see extreme cold even though the system is warm.
Right.
So, for a person in Miami, Christmas Eve and Christmas Day that just passed, we set records for the coldest maximum temperature for those 2 days ever experienced on those particular dates. And yet it was almost like you distilled the entire winter into those 2 days because the rest of winter was extremely warm, and we ended up with one of the warmest winters in Miami's history, and those records date back to the 19th century. So even though we had 2 really cold days, I mean, to have somebody come out and say, well, what about this global warming? Look at how cold it is. Well, I mean, that just doesn't make much sense. The long-term trend is it is warming.
So let's talk about the sea. So we saw this clip from Louisiana, and then Rob's clip looking at the Florida coastline, particularly around Miami. Sea level rise is this global phenomenon, but the sea is not, it's different depending on where you are. So why is that, Jeff? Do you want to talk about that?
Yeah, we have global sea level rise, which is dependent on the land on ice, the glaciers melting, and they run into the sea. And as the temperature of the ocean warms, the ocean water expands, and so it takes up more room. And then you also have local land change. So Louisiana is subsiding and sinking because of all the oil and gas extraction, and also because of the river being levied the whole way. And then the third thing is there was an article that just was in the Washington Post about a Nature article that just came out. And here on the Gulf of Mexico, over the last 10 years, sea level has been rising at a rate of 1 centimeter per year, and it's just phenomenal. And it's the water comes in from the Caribbean and it flows into the Gulf through the Straits of the Yucatan, and it goes into the Gulf and then it flows out through the Florida Straits. And as the Atlantic circulation, the thermohaline global conveyor belt, is weakening, water is piling up in the Gulf, and so we're having phenomenal rates of sea level rise right here, right now.
So you're having more sea level rise than other parts of the world might be having.
Yeah. As I said, Louisiana is the highest rates, and now that rate is extending all the way into the whole Gulf.
In Miami, the sea level has risen 7 inches in less than 30 years. And, you know, it may not sound like a lot, but it means a lot. I mean, if a storm surge comes, that storm surge is going to penetrate much further inland than it would have otherwise and affect many more structures than it would have otherwise. Not to mention just the sunny day floods that we get in South Florida, which is, you know, it may not have rained for 3 weeks, and yet the streets are full of salt water in Brickell, in Coconut Grove, in Fort Lauderdale. I mean, there's all these neighborhoods where salt water is just standing there.
So why is that? Where's that water coming from if it's not rain?
It's so the tide. When you get the springiest tides of the year, these are the tides that there's a big difference between the peak and the trough of the tide. Well, that happens a lot in the fall, so between August and November or so. And those king tides, as they're known, you know, there's spots in the Florida Keys, for example, which we should definitely talk about, that become inaccessible. You know, there's homeowners that cannot access their homes unless they have one of those high profile, you know, big Jeeps type of thing, which of course they have to drive it through salt water to get to their home. Lord knows what that'll do to their vehicle after a couple of years, right? So it's for the Keys, it's existential, and it's now. It's not in 2070. It's now, between now and 2040, that they're going to have to make some really difficult decisions and choices.
And part of this is that Florida has a very low coastal gradient. If you've ever been swimming at St. Mark's, you can walk out a mile and you're still in waist deep water, and it's the same way when you walk inland. And so 7 inches of sea level rise can correspond to tens to hundreds of feet of shoreline retreat. And that's what we're seeing.
So a lot of cities around the world are working on, you know, thinking about and planning and potentially putting a lot of money into barriers. Is that realistic for the Florida coastline at all?
It buys a little time, but, you know, and the state of Florida is doing a lot about mitigation and adaptation. But if, you know, we can adapt, but it's like we're in an arms race with nature, because we keep putting these greenhouse gases, CO2, methane, nitrous oxide, into the atmosphere, and that makes it warmer. And so the sea level rises. So we have to build our seawalls higher. We have to put out these things with the holes in them everywhere. But the sea level keeps rising, and say, oh, by the year 2100, sea level is going to be 30 inches higher. Well, what about the year 2200? What are we thinking about? You know, like, we're just in an arms race. And so there's adaptation, and then there's mitigation. And mitigation means doing something about all these greenhouse gases, using solar power, using wind power. We've got to stop getting our energy from digging stuff up out of the ground and burning it. That's prehistoric. That's cave people.
So going back to the barriers, and congratulations, Rob, on your piece. And I thought it was really creative. I love the metaphor about the NFL players. I mean, just, you know,
Yes.
explaining this idea of how heavy water is, and once it gets moving, how powerful it is, and that, you know, so much of storm damage is not from the wind, but from the waves. But give us an update of where are they at, you know, in terms of that development. You know, have they actually installed it? You know, has it ever been tested in a hurricane before? What's going on?
Just as I was finishing that piece, so towards the end of March, they installed sea hive barriers at a test site called Wahoo Bay in Pompano Beach, Florida. And so this is in the Hillsborough Inlet. And I went on Google Earth today and measured it. It's a very small little inlet. It's like maybe 6 or 7 football fields worth of water in there. So it hasn't really been tested. We don't know when it'll get tested by hurricanes. What they're going to do in the short term is in June, they're going to launch a website with cameras, and they're really focusing on right now is building that as a habitat. And so you'll be able to watch these cameras, and they'll have mangroves and coral reefs. And what they hope people will see is, all the fish and the sea life that goes there. And there's a little marina there, and they hope that it will help with fishing. And I think that's a way that they're hoping to sell this as a solution to people. It's an attractive barrier that increases, it has a lot of other value than as a barrier. And when the hurricane comes, then they'll see, I guess.
Now, so you talked about that in the context of a place like Miami. Does something like that make sense up here in the Panhandle, or what do you need in the Panhandle?
Well, in the Panhandle, we have, he talked about, those natural ecosystems, and, they don't have time or space for them down there, to grow them. We have that here. We have the St. Mark's National Wildlife Refuge, and we have, places where there's miles of marsh, sometimes, backed up by miles of forest. And so we have, salt marsh ecosystems and seagrass beds. And even though oyster fisheries are suffering, we'll have coastal oysters, acting as a barrier. So here, at least in our immediate vicinity, I don't think have as much of a need for, installing a barrier.
So you need to keep those, though.
Yeah.
Although we're spending a tremendous amount of money on beach renourishment at the Cape San Blas and in Gulf County and Panama City Beach. We are pumping up a lot of sand on the beach, and it costs millions of dollars. And the taxpayers are funding that to support the owners of property on the beaches.
I mean, long term, it's just a futile
It
exercise.
doesn't last that long. No.
Right. Yeah.
I've got pictures.
So, John, knowing how destructive and dangerous these storms can be, forecasting is so incredibly important. How are we doing in terms of your forecasting abilities? And is that changing at all with climate change? Is it making harder to predict what's going on with a powerful storm? Or is it the same? Can you talk about recent storms, and are there any things that have surprised you that you think are influenced by climate change?
Well, I don't know about my forecasting ability personally, but I can tell
How's
you
your
that
forecasting doing,
generally
John?
speaking, hurricane track forecasts have improved tremendously. And this is in good part not just because of our better understanding of the science and the physics of the hurricane and the environment surrounding the hurricane, but of course it's also because of the power of computing. We do model what the atmosphere does, and we use mathematical equations to define in 3 dimensions and try to project forward what the atmosphere will do. And boy, those models have gotten really good. So we're good at track forecasting. The intensity forecasting can still be a challenge, especially those rapid intensification cycles, which is an increase in 35 miles per hour in the wind speed in 24 hours or less. So, going from an 80 mile per hour storm to a 115 mile per hour storm, that would be a rapid intensification cycle for a hurricane. I have seen, however, just in my experience, there's better forecasting of those type of events. The National Hurricane Center dares forecast rapid intensification cycles, which they would never mention in the past, and now they do, because we're seeing them so much more often. For me, in practicality, me being on TV still not every day, but as a hurricane specialist in Miami, what this means for me is that I get a lot more gray hairs, which actually I have in recent years. And it's because, if there is a high-end tropical storm, which, if a high-end tropical storm is going to hit me, 60, 70 mile an hour winds, we can deal with that. And the storm surge is relatively minor. It's not a big deal. But if there is a high-end tropical storm that that there's a chance that it could go through a rapid intensification cycle, and between the central Bahamas and the east coast of Florida go from, just a 70-mile-an-hour storm to 115 or 125 mile an hour hurricane, that's reason to worry. And I worry a lot more about that these days than I did in the past, because yes, the more hurricanes are reaching category 4 and 5 intensity around the planet. It's not that there's more tropical storms necessarily, despite our run in 2020 and 2021, which we had 51 named storms in 2 years. All right, so it was busy in the Atlantic. Despite that, though, global trends are not for more tropical cyclones forming, but global trends are most definitely showing that we're getting, the ones that form are having a greater possibility of reaching those very catastrophic intensities.
And that's basically because the water is warmer.
That's basically it, because the water is warmer. Yeah, there might be a couple of other things going on as well, including less aerosols in the atmosphere, which is helping to warm the waters. But you all have to realize that when you get an Ian, when you get a Michael, an Irma, a Harvey, a Maria, those events are the ones that there's a before that and there's an after that. And you can ask the people in Mexico Beach, and you can ask the people in Fort Myers and Sarasota, and you ask the people in Puerto Rico. There's a before that event and an after, because those catastrophic 4s and 5s just are absolutely devastating and have long-lasting impacts way beyond the 2 or 3 months of immediate recovery. The economic impacts are just tremendous. And I'll say one more thing. I was doing, maybe we were preparing our hurricane special. This is something that newsrooms do and hurricane markets like Miami and Tampa. We were preparing our hurricane special, and I had an opportunity to go to MIT to interview Kerry Emanuel. You might be familiar with that name. Kerry Emanuel is a climate scientist, and he works a lot with hurricanes. And something that really struck me, I went for this interview after Hurricane Maria, and he showed me, here is the return period of an event like Maria to Puerto Rico in the 20th century climate. The return period of something that devastating to Puerto Rico is once every 200 years, based on the 20th century climate, once every 200 years. The return period by the end of this century would be one every 20 years. So I rhetorically ask, how can a society even be resilient enough? That word resilience has limits, right? I don't care how much a politician tells you, well, we're going to be resilient. Yeah, resilience has limits. And how would a society be able to deal with that type of economic impact once every 20 years? I think it would be very difficult.
Well, I want to talk about a different kind of resilience. We talk about drought and fire, which we didn't look at tonight, but there is a major sequence in our film about drought and fire out west, and really looking at these, huge mega fires that have been ravaging the West. I think something like 25% of California forests have burned in, I think, the last 10 or 20 years. But what's going on here? Rob, you've been doing some reporting on this.
Right. Well, it's built into covering ecology in North Florida. It's something I'm always covering, but it is our second NOVA story as well. It's more than once I've been reading a story on California wildfires where they say, if California would do it the way Florida did, it wouldn't be as catastrophic. And it's kind of an accidental thing, and after the Civil War, a lot of wealthy Northerners came down and bought land to hunt quail, and they got into quail thrives in this open longleaf pine landscape, which is maintained with fire. So their fire crews developed a methodology of burning on a regular basis. It became a science, and it's what we do in Florida and South Georgia now, is to burn these ecosystems. We're in what we call the lightning capital of the world, and so these ecosystems have evolved to adapt to regular fire. And so what regular fire does, other than the ecological benefits to all the animals and the diversity of plant life, in the understory of a longleaf pine ecosystem. What it does is, on a regular basis, if you burn regularly, is it burns the fuel loads and keeps the fuel loads low. If you ever go to a prescribed fire on a place that's regularly burned, it's a really slow creeping fire. It's kind of pleasant. We shot our segment a couple weeks ago. I brought our social media team and radio reporter, and we had a fun. It was a fun day. It's these creeping little fires, and we go and it keeps these fuels from building up as they have out west, and they become catastrophic wildfires, which are detrimental to the ecosystem.
But so you've been able. That's a good news story, and in some ways that's a solution to prevent major wildfires.
Correct.
Even when there's drought.
Even when there's drought, yeah. The biggest problem we had was after Hurricane Michael, where we had a lot of fallen trees, and that was one of the first things a lot of land managers did, was to go out and clear timber, and it was a kind of a large operation for a lot of them. And then we had that large wildfire. We did have a large wildfire in Panama City last year, and it was a lot of those fallen trees from Hurricane Michael they caught.
That's another kind of counterintuitive thing, that a hurricane can lead to a wildfire.
Mm-hmm.
Do you have some questions for me? Well, while I'm looking through these, I wanted to turn the conversation to mitigation and Jeff, something that you were mentioning, and I know that you do a lot of work studying methane. And we have a program I mentioned coming out next week, really looking at how we could get carbon emissions down to net zero by 2050. And methane is a big part of that. Can you talk a little bit about what is methane and what's so special about it, and why can it make a big difference in either direction?
Okay. Well, methane is what we call natural gas, and that's produced geologically by high temperatures in the earth. Methane's also produced biologically in like landfills and swamps and wetlands. And so it's a product of anaerobic metabolism. And so the thing about methane is that it has a greenhouse gas effectiveness about 80 times that of CO2. It's a much stronger infrared absorber than CO2. And it has a half-life in the atmosphere. Well, its lifetime in the atmosphere is only about 10 years. And so, and a lot of the sources of methane are point sources. And so methane is a place that we could act. If we could reduce methane emissions to the atmosphere, we could change the heating capacity of the atmosphere pretty rapidly, on a human lifespan, because CO2 has a lifetime in the atmosphere of hundreds of years. And so we could act on methane and get it down, and we could start to mitigate these climate effects that are so disturbing right now. And one of the things, there's a famous oceanographer called Wally Broecker. And Wally Broecker, he's the one that discovered the global thermohaline circulation in the ocean. And he talks about how human civilization really flourished in the Holocene because we had this very quiescent climate, a very gentle climate. We were able to start with agriculture, and so we really flourished in this gentle climate of the Holocene. But now we're kind of going into this new geological epoch, the Anthropocene, and because of the enhanced variability of climate, we're going to face more challenges.
All right, there's a ton of questions here. Really great questions. Some very provocative. Here's a question. Do you think we actually have enough time to reduce greenhouse gases and stop rising sea levels?
Well, we have to have enough time. We have to assume that we do. So we have to act like we have the time to do it. But we need to start now and get busy.
Yeah, so I mean, I think it's important to realize that, sea levels would be rising anyway because we are in the interglacial period. The problem is that they're rising faster than they otherwise would, just based solely on, if it was only left up to natural forcing, they wouldn't be rising as quickly as they are. And we wouldn't be worrying about, not just 30 inches, but the possibility in some of the more extreme projections of 6 feet of sea level rise by the end of the century, which is not out of the realm of possibilities. All right, because unfortunately, the science doesn't know enough to be able to tell you precisely how many centimeters of sea level rise we're going to get by 2050 and 2080 and 2100. We're not sure, right? But it'll depend on a lot of things. It depends on some of the ice shelves in Antarctica. You've heard of the Thwaites ice shelf down there. Some new research where some areas of Thwaites underneath it, where the water is, are melting faster and others are melting slower than they thought. But in balance, there's still a great deal of worry about when that finally melts. And then if that detaches from the Antarctic Peninsula, then the glaciers that are on land are going to start to pour out a lot faster into the ocean and therefore rise our sea levels faster. So, there's a lot of variables that we don't know. And that's why it's so hard to project exactly how much sea level rise we're going to get. But sea level rise for some parts of this planet is an existential issue.
So this is a question that I wondered about, and a lot of people talked about it. During the pandemic, did the reduction in human activity, such as, so many people staying at home, not driving, airlines, did that create any measurable slowing of global temperatures? And the other part of that next question is, would a national moratorium on use of cars 1 day a week make any difference?
Yes and yes. It didn't really slow down the temperature increase, but it slowed down the rate of CO2 release. It was still going up, but it went up at a slower rate.
How should Florida residents prepare for stronger and more frequent hurricanes, even those who may not be in evacuation zones?
So quality of construction is really, really, really important. Okay. And one of the concerns is that, when you look, of course, there's so many strings pulling at these different important resilience aspects that we have, right? Because it makes a lot of sense to build as strong a possible house as you can, right? But it also costs more money. And the building lobby, the construction lobby says, no, don't make us build, stronger homes, because then it's going to be harder for us to sell them because they're more expensive in the first place. And that's why you see construction codes being stronger in some parts of Florida, weaker in others. And if you just go a few miles inland, the requirements are much, much weaker than they are if you build immediately along the coast. There's been recent research, I'm sure you saw this paper, where we are seeing that hurricanes, because A, they're stronger, and B, they're maintaining their strength longer as they go inland. It turns out hurricane winds are impacting many more communities further inland that have ever been affected. So quality of construction is going to be really, really important, and I think that would be one very important way.
So you think the house of bricks rather than the house of sticks or straw, right?
Right. Build like they do in the Caribbean. You look at homes in the Dominican and Puerto Rico, and these are not wealthier places than here, and yet construction there is, it's rebar, cement blocks, a poured concrete roof on rebar. Maybe we ought to consider that. In South Florida, you're starting to see some of that, some of these squarish type of homes. It's very stylish, by the way. They're fabulous, but they're much stronger. Instead of the wood trusses, and oftentimes not properly anchored to the tie beam, which in turn is not properly anchored to the rest of the structure. There are some glaring weaknesses in construction all across the U.S., but even here in a hurricane-prone state like Florida.
All right, I'm not going to read this whole question, but I think this might have been a plant by Jeff because it's asking about septic tanks, which I believe, no, isn't that? Aren't you interested in septic tanks?
Septic tanks. What about them?
Well, tell us about them. What are they contributing to climate change, and to greenhouse gas emissions?
No, I don't really think so. Septic tanks?
Oh no.
No, they're not. But
Okay.
but so I've got,
is this related to algae blooms?
yes.
blooms, yeah.
So
Algae
yes,
blooms.
they're
Okay,
contributing
sorry.
to that.
The
So
sargassum.
All right, so-
you can talk about nutrients. You want to talk about that?
Yeah, the sargassum that we're seeing coming towards Florida is.
So these are these giant seaweed blobs in the Atlantic, right?
Yeah.
Coming towards Florida.
Although that's mostly fueled by agricultural nutrient inputs, mostly in South America, coming from the Amazon. So I mean, septic tanks have their own issues and problems, and it affects the springs, like Wakulla Springs. It might affect our local coastline, but I don't think it's a global problem.
Okay.
Well, I do have something to
Yes.
say because septic tanks in parts of the state are damaging the coastal of wetlands. Whether it's the bays, the seagrasses, for example, in Biscayne Bay in South Florida, we're getting seagrass die-offs everywhere, and part of that is blue-green algae that's forming at the surface, blocking out the sunlight and not allowing the seagrass to be able to, photosynthesize. So
It's true. The manatees are starving because.
and the manatees are starving because of it, right? So septic tanks are a big problem, especially in this new climate in the Anthropocene, because what we're seeing is that the water table is higher all across the state, but where I'm from in South Florida, the issue with a higher water table, which is being pushed up by the encroaching ocean, right? Again, remember, 7 inches of sea level rise in less than 30 years. So as the sea pushes in, the water table is higher. Septic tanks, which used to sit in dry ground, as they were designed to be, are suddenly, the bottom of the septic tank is sitting in water. And therefore, the septic tank stops working like it was designed to work. And all that poop is running out into the aquifer and into Biscayne Bay. And it's also producing blue-green algae outbreaks, toxic algae outbreaks along the St. Lucie River and estuary. And the I can never pronounce, the Colassahootchee. Did I get that right? Yeah, on the one that heads west out of Lake Okeechobee, that one as well. So sorry, I had to say something about
I'm sorry.
tanks.
I'm sorry. It was John who planted the question, not Jeff. Okay. This was someone very special handed me this card. It says, "Stop the storms." And it says, "If the problem is the wind blowing the waves, why do we not build something to block the wind from the waves?" Seems very straightforward.
Try to stop the wind.
Yeah, no, I mean, listen, it's a valid question. I don't see any practical way that you could do that. It's like when I hear, ways to eliminate hurricanes. Oh, let's tow icebergs. This is stuff that I get as a broadcast meteorologist. People sending me ideas. Let's tow icebergs from the poles to cool the ocean in the tropics. I mean, it'd be like throwing an ice cube, and it's just not going to work. Or, of course, not too long ago, a big, well-known leader said that we should nuke the hurricanes, right? But I mean, the amount of energy that hurricanes put out in just an hour blows away, the energy that one nuclear bomb can possibly do. And then, of course, we'd have radioactive hurricanes, not to mention the other problems. So.
But to give a realistic question, the realistic answer is that just these winds, the particular winds that you're talking about in a hurricane, are just so powerful. That would just be too difficult.
I don't think we can stop the wind.
We can't stop those.
Yeah, it'd be like spitting into the wind.
And how high? I mean, where do you put it? A wall? Is this a mobile wall? I mean, it's just I don't see the science behind it.
Yeah. So, but interestingly, I was asking about when we're talking about reducing carbon emissions and looking at ways, which we talk about again in our show next week, how do we produce energy? How do we live, without burning all these fossil fuels? But Jeff, you can address this, but whether we can, here in Florida, whether wind is much of an option or not.
Well, we have plenty of sunlight, so I think we should do the solar power route. And some good news is that this year, energy production from wind and solar outpaced energy production from coal. So we're moving in the right direction, and we just have to keep going that way. We have to stop methane emissions. We have to reduce CO2 emissions. We have to take on nitrous oxide, which comes from agricultural production. And all these things can be done. And, the current administration in Washington has gone a long way of putting money where our mouth is, and we're doing things about climate change. There's a methane tax in the new bill that they passed last Congress. And so the Congress has really stepped up, and I think that we're on the right track.
John, do you have final thoughts?
Yeah, listen, you're right. The IRA, that piece of legislation is the biggest action on climate that's ever been taken by Congress in this country, and I think it's really important. Europe is doing a lot as well, probably more than we are, to mitigate greenhouse gas emissions. But there are also tremendous challenges, right? We're talking about getting to net zero by 2050. It means a lot of renewable energy. Renewables has its challenges because it's intermittent, so we need a lot of battery storage. That technology needs to ramp up and scale up at a better cost so that we can store that power and use it 24/7. I think, this is my very personal opinion, I think people need to, and keep in mind, I'm an atmospheric scientist, but I have a master's in environmental science. I'm as much an environmentalist as anyone else in this room. But folks, in my very personal opinion, nuclear power needs to be part of this portfolio, because we need to get from point A to point B, and we need to do it quickly. And yes, it's expensive, but there's ways to build modular nuclear power plants that are not as costly as the others and are safer because they're cooled by sodiums, by salt, instead of being cooled by water. Plus, fusion may not be too far away, and that's just a couple of decades away potentially. And it might be for rich countries that the rich countries will do fusion, and maybe the not so rich countries can still do fission, which is the traditional nuclear energy. But I think it needs to be a part of the portfolio if we're going to be realistic about, getting away from fossil fuels. My very personal opinion. You don't all have to agree with that.
Rob, do you have final hope? What are you hopeful about?
What am I hopeful about? Oh,
I can say what I'm hopeful about. I'm hopeful about great science and climate communication and the local reporting you're doing and all the work that WFSU is doing.
well, thank you.
And doing this work, one of the things, again, what I'm hopeful about is seeing the number of people who are studying this issue, who are working on it, who are making progress. Please check out our film next week, which really does show how far we've come already in this work in reducing greenhouse gas emissions. So next Wednesday, check out WFSU will broadcast Chasing Carbon Zero on Wednesday night at 9. Check out these films. Weathering the Future is streaming right now on pbs.org/NOVA, the PBS app, and NOVA's YouTube channel. I want to recognize Kiki Kapani, who was the director and producer of the show. Next week, we are having a virtual event with Kiki and others from the film. If you want to check it out, check out the NOVA website for a link there. Also, please fill out a survey. Let us know. Give us the feedback on the event. It really makes a difference. It should only take you a few minutes. It would mean a lot for us. I also want to mention we recently published a collection of free educational resources from Weathering the Future, accessible for free on PBS Learning Media that are for teachers and students. And we'll be hosting a virtual field trip next week. Check out the Nova Education website. That's a wonderful way for students in classrooms to, talk to scientists directly on Zoom. I want to thank all the panelists. I also just want to take a moment to thank everyone who supports this important work for these films and this project. It's the Corporation for Public Broadcasting, the GBH Planet Future Fund, the Nova Science Trust, and you. Thank you to all of you, especially those who, support public broadcasting, who support WFSU, who support the Challenger Learning Center, and really any of you who watch and listen and value our work. We could not do this without you. And now I will pass things over to Kim to say good night.
Thank you so much. What a great discussion. And thank you for you all taking time to come and be part of the conversation. You can take a picture of that, and that will take the survey right to your phone if you don't want to do the paper version, save paper. Alan, thank you.
Do I get the last word? I'll give it back to you. I just want to thank everyone for coming out tonight. I know there's a lot of things going on, and this is really important. I want to thank the Nova, WFSU, the Corporation for Public Broadcasting. I especially want to thank everybody behind the scenes, especially my folks here who worked really hard to make this happen. So hopefully you enjoyed the experience of seeing this incredible content on the largest screen in Tallahassee. That's a big deal. Mostly, I just want to add, so this is really important, and we can make an impact. All of us can make an impact, but we're not likely to solve this. The folks who are going to solve this are the next generation. And I saw a couple of young folks here, and that's who I'm looking at to solve these problems. And that's why I'm so passionate about what we do here at the Challenger Learning Center, every day inspiring young people to pursue careers in science, technology, engineering, and math. And that's how we're going to solve these problems in the future. So thank you all.
All right, Jeff.
One thing we were talking about at lunch is that individual actions are really, really important, but we need to act as a society. We need to act collectively and politically to take on this task.
Your advocacy and your votes will do a lot more than composting in your backyard. Okay.
But also do compost in your backyard.
Yeah, don't stop composting.
Yes.
Don't stop that.
Every tool in the shed.
Thank you, everyone.
Bye-bye. Have a good night.